Hello everyone, welcome back to the Atharva Academy. Myself Chinmay Daduk. In previous video, we have discussed that how to find normal stress and shear stress at any plane of this body. And we have also seen different equations to find out normal stress and shear stress. Fine? Now today in this video, we are going to discuss Mohr's circle. So what is Mohr circle? It is graphical representation of stresses at a point. Means by using this Mohr circle, we can represent this type of stresses on any graph. Let's say if any body having this type of stresses, here in x direction there is normal stress sigma x and in y direction there is normal stress sigma y. And we apply shear stress tau xy on all the surface of this body. So we can represent this condition by Mohr circle, and it is easy to find out value of sigma 1, sigma 2 and tau max by using this Mohr circle. Fine? So now we are going to understand that how to draw this Mohr circle. So to draw Mohr circles, we will take this type of coordinates, in which this direction we will take sigma means normal stress, and in this axis we will take shear stress. Here on the right side we will take positive normal stress, and on the left side we will take negative normal stress. And similarly on this side we will take positive shear stress, and on this side we will take negative shear stress. Now to draw Mohr circle, for this condition, first of all we have to plot 2 points. Now here you can see that there is normal stress sigma x on this surface of body, and it is tensile in nature, so it will be on right side of this point. And here we are assuming that sigma x is greater than sigma y, means stress in x direction is greater than stress in y direction. Fine? Now here you can see that on this surface there is this sigma x normal stress which is tensile in nature. So here this sigma x will be on right side of this point. So let's say sigma x is somewhere here, and here this distance is sigma x, and also there is normal stress sigma y on this surface, and it is also tensile in nature, so it also will be in right side of this point. So let's say sigma y is somewhere here, and here this distance is sigma y. Here we assumed that sigma x is greater than sigma y, so here I take sigma x here and sigma y here. Fine? Now if it is compressive in nature, then we have to take this stress at the left side of this point, means we have to take sigma y here. We know that here we take this clockwise direction theta as positive, and similarly we will take this stress which is in clockwise direction as positive. Here this stress is positive because you can see that if we take this point, and you can see that this shear stress will try to rotate this body in the clockwise direction with respect to this point. Fine? So for our case we are going to take clockwise direction as positive direction, and it is acting along with sigma x. Fine? So from this point this shear stress tau xy will be on positive side, so it will be somewhere here. Here I take vertical line because there is shear stress in vertical direction. Fine? And if you will see here on this surface there is this shear stress tau xy which is in anti-clockwise direction, because this shear stress try to rotate this body in anti-clockwise direction. So we will take this shear stress as negative. So from this point it will be vertical line like this, and here this distance is tau xy, and similarly this distance is tau xy. Now here we are going to join these 2 points by a straight line. So here this straight line will be diameter of Mohr circle, and here this point is center of this Mohr circle. So if you will draw a circle by taking this line segment as diameter, so you will get Mohr circle. Now in this diagram you can clearly see that this circle is Mohr circle. Here this point is point sigma x, means normal stress in x direction. Here this point is normal stress in y direction, that is sigma y. Here this distance is tau xy, and similarly here this distance is tau xy. When you will join these 2 points by a straight line segment, then you will get this angle as 2 theta. Here this plane is at angle theta, but in Mohr circle you will get that angle as 2 theta, means it is double of this theta angle. So I hope that you understand how to draw this Mohr circle. Now from this Mohr circle we can find out value of principal stress sigma 1, sigma 2, and we can also find tau maximum. Here you can see that this Mohr circles touches this normal axis at this point and this point. Means at this point value of stress is 0. Tau is 0. And we know that plane on which shear stress is 0 is called as principal plane. And value of normal stress at principal plane is called as principal stresses. So here this point shows maximum value of principal stress and this point shows minimum value of principal stress. So here this distance from this point to this point will be maximum principal stress, that is sigma 1, and here from this point to this point this distance shows minimum principal stress, that is sigma 2. So here this both points shows maximum and minimum principal stresses. Now here maximum value of shear stress is at this point. Here if we draw one line from this point to this point, then it will be radius of this Mohr circle. And here radius of this Mohr circle gives maximum value of shear stress, that is tau max. So we can write that radius of Mohr circle is equal to tau max. And here from this point to this point this line shows radius of this Mohr circle. So from here we can find out value of tau max, means we can find out value of radius. Now let's say this point is point A, this is point B, and this is point C. In ABC triangle this angle is 90 degree. So we know that this distance is tau xy, and here this distance will be sigma x minus sigma y by 2. Right here from this point to this point it will be sigma x minus sigma y, and this distance will be half of that. So now if you find radius of this Mohr circle, then it will be under root sigma x minus sigma y by 2 square plus tau xy square. Fine. So from here you can find out value of tau maximum, that is maximum shear stress on this body. Now understand that if we take these 2 points, this point is point sigma x and this point is point sigma y. So if we take this line segment between these 2 points, then you can see that this point is the midpoint of this line segment, which will be sigma x plus sigma y by 2. Fine. And you can see that this is the point which is center of these Mohr circles. So we can say that center of Mohr circle is sigma x plus sigma y by 2, 0, because on this point value of shear stress is 0. So this is the coordinate of this Mohr circle's center. Fine. We have discussed that radius of this Mohr circle is equal to tau max is equal to sigma x minus sigma y by 2 square plus tau xy square under root, and center of this Mohr circle is at sigma average comma 0. And here this sigma average is sigma x plus sigma y by 2. Means here this point is center of this Mohr circle. Now from this Mohr circle we can find out equation of sigma 1 and sigma 2. Now here we know that distance between this point and this point is sigma 1 means maximum principal stress. And to find out this distance we have to take sum of this distance from this point to center point of this Mohr circles, and from this point to this point, that is the radius of this Mohr circle. Now what is this distance? It is sigma x plus sigma y by 2, right? That we have found here. And what is the radius of this Mohr circle? It is this value. So it will be under root sigma x minus sigma y by 2 square plus tau xy square. So this is the equation to find out maximum principal stress in the body. Now we can also find minimum principal stress from this Mohr circle. For that we have to take distance between these 2 points. And to find this distance we have to take this distance minus this radius of this Mohr circle. And we know that this distance is sigma average, that is sigma x plus sigma y by 2 minus this radius, that is under root sigma x minus sigma y by 2 square plus tau xy square. Fine. So you can directly get value of sigma 1 and sigma 2 from this Mohr circle. Now we will take different types of examples so that it will be clear to you that how to draw this Mohr circle for different types of examples. Fine. Now in first case we are going to draw Mohr circle for biaxial loading condition. Means we have this body and in which this direction is having sigma x as normal stress on this both surface, and in y direction this body is having normal stress sigma y on this both surface. And here this normal stress sigma x and sigma y is tensile in nature. So we are going to draw Mohr circle for this case. First of all we will mark this point of normal stress sigma x and sigma y. Here we are assuming that sigma x is greater than sigma y. So let's say sigma x is somewhere here and sigma y is somewhere here. Now in this case there is no any shear stress, so there is no need to mark point of shear stress. So here we are going to draw circle between these 2 points. So it will be something like this. So here this is the Mohr circle for biaxial loading condition, and here there will be center of this Mohr circle, and here distance between this origin and center of this Mohr circle will be sigma x plus sigma y by 2. And here what will be the radius of this Mohr circle? It will be this distance, right? Here distance between these 2 is sigma x minus sigma y. Fine. Here distance between this point and this point is sigma x, and distance between this point and this point is sigma y. So this distance is sigma x minus sigma y, and that is the diameter of this Mohr circle. So we can say that radius of this Mohr circle is sigma x minus sigma y by 2. And we know that here tau maximum will be at this point. And here this is the radius of this Mohr circle. So we can say that tau max is equal to sigma x minus sigma y by 2. Fine. Now here we know that these 2 points shows maximum and minimum principal stress in this body. Here this point shows maximum principal stress, that is sigma 1, and here this point shows minimum principal stress, that is sigma 2. So from here we can write that sigma 1 is equal to sigma x, right? And sigma 2 is equal to sigma y. So in this case, maximum principal stress is sigma x and minimum principal stress is sigma y. Now let us take another example in which we have this body and we apply stress in this x direction is sigma, and here stress in y direction is also sigma. Means in this case sigma x is equal to sigma y is equal to sigma, and here there is no any shear stress acting on this body. Now we are going to draw Mohr circle for this case. Here in this axis we will take normal stress and in this axis we will take shear stress. Fine. For this surface there is tensile stress sigma is acting on this surface. So we have to mark this point, and here distance between these 2 points is sigma. Now on this surface there is also tensile stress sigma is acting. So for that there will be also same point, this point for this stress, right? And here this distance is sigma. Now understand that for this case value of sigma x and sigma y is same. So there is no distance between sigma x and sigma y. So for this case Mohr circle will be one point on this axis. If we get two different points, then we can join these 2 points by a circle like this. But here we only get 1 point, so we cannot make circle from this 1 point. So in this case Mohr circle is point. And in this case value of sigma 1 and sigma 2 will be equal, and that is equal to sigma. So here this distance will be sigma 1 and sigma 2. And for this case, what will be the value of shear stress? At any plane of this body and at any point of this body, value of shear stress will be 0, right? Because there is only one point on this diagram, and which is on this axis, which is axis of normal stress. And on this axis, value of shear stress is 0. So we will get tau is equal to 0, and it will be in any direction of this body. Means we can say that for all the values of theta, value of shear stress is 0 and value of maximum principal stress and value of minimum principal stress is sigma. Fine. So I hope that you understand how to draw Mohr circle for this type of case. Now let's say we have case of axial loading condition. Means in this case we have stress in x direction, but in y direction we have not any stress. We can also take one example of this type of loading condition. Let's say we have this type of body and we apply axial load on this body P. So in this case value of stress will be P divided by A, right? So this case is going to be the case of axial loading as shown here. Fine. In this case sigma x is equal to sigma, right? And in y direction there is no any stress, so sigma y is equal to 0, and also tau is equal to 0 because there is no any shear stress on this body. So first of all we are going to mark these 2 points. Here this stress is tensile stress, so we will take one point at the right side of this origin. Let's say we will take this point, and here this distance is sigma. Means here this point denotes the stress on this surface, that is tensile stress sigma. Now in y direction there is no any stress, means sigma y is equal to 0. So we will get this point on origin of this diagram. So now we have 2 points, and from these 2 points we can draw Mohr circle. So for this loading condition Mohr circle will be something like this. Here this point is the center of this Mohr circle, right? And here this distance is the half of this whole distance sigma, right? So here we can say that radius is sigma by 2. And if radius is sigma by 2, then we can say that tau max is sigma by 2 in this loading condition. And in this case, this distance is going to be the sigma 1. Means here maximum principal stress sigma 1 is equal to sigma, right? And here this point shows minimum principal stress in this body. And here you can see that sigma 2 is equal to 0. So in this case minimum principal stress is having value 0. Now let's say in this case we apply compressive load on this both surface in x direction, and let's say it is sigma. We don't apply stress in y direction. So this case is going to be the case of axial loading condition. Let's say we have body like this and on which we apply compressive load P like this. So in this case value of stress will be minus P by A, right? Because this load is compressive load, so here we have taken negative sign. So for this case loading condition is shown here. In this loading condition sigma x is equal to minus sigma, sigma y is equal to 0 and tau is equal to 0. Fine. So first of all we are going to mark these 2 points. Here sigma x is equal to minus sigma. So it is compressive stress. So we have to mark this point at left side of this origin. So this minus sigma will be somewhere here. And here this distance is sigma. Now we are going to mark this point where sigma y is equal to 0. So we know that at this point sigma is 0. Fine. So now we have these 2 points, and by using these 2 points we can draw Mohr circle. So at this time Mohr circle will be something like this. Fine. Now from this Mohr circle we can find out sigma 1, sigma 2 and tau max. Fine. Now here this point will show sigma 1, this point will show sigma 2. So in this case value of sigma 1 will be 0, right? Because distance of this point from this origin is 0. So in our case value of maximum principal stress is 0. Now here what will be the value of minimum principal stress? To get sigma 2 we have to take this distance. And here this distance is sigma. And it is in the negative direction, so we will take sigma 2 as minus sigma. Means in this case minimum value of principal stress is minus sigma. And what will be the value of tau max? Tau max is radius of this Mohr circle, that is this distance, right? So here diameter of this Mohr circle is sigma. So radius of this Mohr circle will be sigma by 2, right? So tau max means maximum shear stress in the body is sigma by 2. Now let's say here we apply compressive load in y direction also. And here stress in y direction is, let's say, sigma. Means this case is going to be the case of hydrostatic pressure. Means we can say that in all the direction value of stress sigma x is equal to sigma y is equal to minus sigma. Means we can also say that if any body is submerged under the water, then in that body there will be value of stress in x direction and y direction, and z direction will be equal to minus sigma. Here we are taking 2D loading condition, means we are taking stress in x direction and stress in y direction as minus sigma. And in this case we are taking tau is equal to 0 because there is no any shear stress on this body. So for this loading condition what is going to be the Mohr circle? Now to draw Mohr circle in this case we will mark 2 points. Here sigma x is equal to minus sigma, so it will be somewhere here, right? Because it is negative stress, so we will mark this point at the left side of this origin. So here this distance is sigma and it is sigma x is equal to sigma. Fine. Now on y direction there is also same value of stress, that is minus sigma. So again we will get same point on this diagram, right? So now in this case also we have 2 points at same coordinate. So in this case we will have Mohr circle as a point on this axis, which is the axis of normal stress in the body. And for this case value of sigma 1 and sigma 2 will be same as minus sigma. And we can also understand that in this case value of shear stress is 0. Here we get this point as a Mohr circle, so we can say that in all the direction of theta value of stress is same, that is sigma 1 is equal to sigma 2 is equal to minus sigma and tau is equal to 0. Means here if you will take any plane, it may be this plane or this plane or it may be this plane. In all this plane value of sigma will be minus sigma and value of tau will be 0. Fine. Now in next case we are going to take case of pure shear in the body. Means if we have any body, let's say cylindrical body, which is fixed at left hand side, and we apply twisting moment on this surface, let's say in clockwise direction when we view from this side. So in this case there will be pure torsion in the body. And if we will take any point of this body, let's say if we will take this cube from the surface of this body and we will see stress on this body, then it will be pure shear stress in this body, and that can be shown by this type of stress. And here value of stress is, let's say, tau. So if you will take any point from the surface of this body, then you will find this type of loading condition on this point. In the question, if this type of figure is given and we have to draw Mohr circle, then how we can draw it? So first of all, here you can see that sigma x is equal to 0. In x direction normal stress is 0. In y direction normal stress is 0. So sigma y is also equal to 0. And tau xy is equal to tau. Now first of all we will mark stress on this surface. So in this surface sigma x is 0. So here we will get this point, right? And here on this surface value of shear stress is tau. And it is acting in clockwise direction with respect to any point of this body. Means this shear stress will try to rotate this body in clockwise direction with respect to this point. So we will take this shear stress as positive. So from this point this shear stress will be somewhere here. And here this distance is tau. Now on the second surface value of normal stress is 0. Means sigma y is 0. So we will get again this point, right? And on this surface value of shear stress is tau, and this shear stress will try to rotate this body in the anti-clockwise direction with respect to this point. So we will take this shear stress tau as negative. So on this diagram it will be somewhere here, right? And this distance is also tau. So now we have 2 points. This is one point and this is second point. And this line segment between these 2 points is going to be the diameter of Mohr circle. So now we can draw Mohr circle from these 2 points. So it will be something like this. And now here you can see that center of this Mohr circle is 0.00. Here radius of this Mohr circle is tau. Radius is equal to tau. Means we can say that tau maximum is equal to tau. And here what is the value of maximum principal stress and minimum principal stress? At this point we will get maximum value of principal stress, that will be this distance, right? And it is radius of this Mohr circle. So sigma 1 is equal to tau, right? And here we will get minimum principal stress, that is this distance, and here this distance is also tau, but it is in the negative direction, so sigma 2 is minus tau. So maximum value of principal stress is tau and minimum value of shear stress is minus tau. And here this is the Mohr circle for pure torsion. Fine. Now see that if you will find these all values, means value of sigma 1, sigma 2 and tau max by using equations that we have discussed in the previous video, then we can also find out value of sigma 1, sigma 2 and tau max. But I think that it is easy to find out these values from this Mohr's circle. If there is shear stress and normal stress acting simultaneously on the body, then we can use that equations discussed in the previous video. Because in that case, it will be easy to find out these values by using equations rather than this Mohr circle. Fine. So you can find these values by using Mohr circle in this type of easy cases. But if complex loading is given, then you can use equations that we have discussed earlier. Fine. Now we are going to discuss Mohr circle for triaxial loading condition. Here you can see that we have this body on which there is normal stress sigma x in x direction, there is normal stress sigma y in y direction, and there is normal stress sigma z in z direction. So in this case there is no any shear stress, so value of sigma x will be equal to principal stress sigma 1, value of sigma y will be equal to principal stress sigma 2, and value of sigma z will be equal to principal stress sigma 3. In 2D loading condition, we have only two principal stresses, sigma 1 and sigma 2. But in the case of triaxial loading condition, means in 3D loading condition, we have three principal stresses, sigma 1, sigma 2 and sigma 3. Now here, if you will mark these 3 points, this point is of sigma x, this point is of sigma y, and this point is of sigma z. And in this case, sigma x is greater than sigma y is greater than sigma z. Fine. So by using these 3 points, you can draw these 3 circles, right? So in the case of 3D loading condition, there will be 3 circles as a Mohr circles. And here, this point shows maximum principal stress sigma 1, this point shows minimum principal stress sigma 3, and this point shows principal stress sigma 2. So I hope that you understand how to draw Mohr circle for triaxial loading condition. Here, this topic is not important. Means Mohr circle for triaxial loading condition is not so important as per the GATE point of view. But here I am showing you only for your understanding. Fine. So I hope that you understand how to draw Mohr circle for different type of biaxial loading condition that we have discussed in this video. If you will understand these examples, then after that it will be easy for you to draw Mohr circle for any type of loading condition. Fine. So now today in this video we will stop here and we will continue in the next video. Till then, stay motivated and happy practicing.